Our universe is vast. It's filled with stars, galaxies, and mysteries. We can observe a lot, but there's a limit. This limit is our cosmic horizon. Imagine a sphere around us. We can only see things within this sphere. This is because light from beyond hasn't had time to reach us. But what lies beyond this horizon? Could there be more? The idea of the multiverse says yes. It suggests that our universe isn't alone. Instead, it's one of many universes. These universes may have different laws of physics. They may have different histories. They may even have different versions of us. The concept of a multiverse is mind-blowing. It's a radical shift in how we view our place in the cosmos. It's a possibility that excites scientists and ignites our imaginations. Let's delve into some of the most intriguing theories about the multiverse. The idea of a multiverse is not new. It has been around for centuries, but recent scientific advancements have given it new life. Today, there are different theories about what a multiverse might be like. These theories come from cosmology, quantum mechanics, and string theory. One theory is the bubble universe theory. This theory suggests that our universe is like a bubble. It's one of many bubbles in a much larger multiverse. These bubbles constantly form and expand. They may collide and interact, creating new universes. Another theory is the many worlds interpretation of quantum mechanics. This theory says that every time a quantum measurement happens, the universe splits. Each split creates a new universe with a different outcome. This implies an infinite number of universes, each representing a different possibility. Then there's string theory. This theory tries to unify all the forces of nature. It suggests that our universe has more dimensions than we can see. These hidden dimensions could hold other universes. These universes might be right next to us, but we can't perceive them. Imagine a pot of boiling water. Bubbles form, expand, and pop on the surface. The bubble universe theory paints a similar picture of the multiverse. Our universe in this view is just one bubble in a cosmic foam bath of universes. This theory arises from the idea of cosmic inflation. Inflation suggests that our universe expanded rapidly after the Big Bang. This expansion could have created regions where the fabric of space-time inflated at different rates. These regions would become separate bubbles, each evolving into a distinct universe with its own set of physical laws and constants. Some bubbles might have conditions suitable for life, while others might be barren and hostile. The bubble universe theory offers a tantalizing explanation for the vastness and diversity we observe in our own universe. It suggests that our cosmic home is just one tiny pocket in an endless expanse of bubbly possibilities. Quantum mechanics is a strange and wonderful world. It governs the behavior of particles at the smallest scales. One of its most mind-bending interpretations is the many worlds interpretation, MWI. According to the MWI, every quantum measurement or event doesn't lead to a single outcome but to a branching of universes. Imagine you flip a coin. In our universe it lands on heads, but in another universe it lands on tails. Every time a quantum event occurs, a new universe splits off, containing a different possible outcome. This means there's a universe where you made different choices, a universe where dinosaurs still roam, and even a universe where you are the ruler of the world. The possibilities are truly endless. The MWI is a controversial idea. It challenges our understanding of reality and raises profound philosophical questions. Yet it remains a fascinating and thought-provoking theory in the realm of multiverse possibilities. Section 5: String Theories, Hidden Dimensions, Vibrating Strings in Parallel Universes. String theory is a leading candidate for a theory of everything. It seeks to unify all the forces of nature into a single, elegant framework. Instead of point-like particles, string theory proposes that the fundamental building blocks of the universe are tiny, vibrating strings. These strings vibrate at different frequencies, giving rise to the particles and forces we observe. But here's where things get really interesting. String theory requires extra spatial dimensions to work mathematically. These dimensions are curled up and hidden from our perception. Think of a garden hose. From a distance it looks like a one-dimensional line, but up close you see it has a second curled-up dimension. Similarly, our universe might have hidden dimensions beyond our three spatial dimensions. These hidden dimensions could be home to other universes, just as different slices of bread can exist within a single loaf. These universes would be parallel to our own, separated by an unimaginable gulf of higher dimensional space. Section 6: The Elusive Evidence. Can we prove the multiverse? The multiverse remains a tantalizing theory, but can we prove it? This is where things get tricky. The very nature of the multiverse makes it incredibly challenging to observe directly. Think about the bubble universe theory. These bubbles are thought to be separated by vast distances beyond our cosmic horizon. This means that light from these other universes hasn't had time to reach us, making them invisible to our telescopes. The many worlds interpretation faces a similar challenge. Each quantum branch creates a separate universe, but these universes are thought to be causally disconnected from our own. This means that we can't interact with them or receive any information from them. String theory's extra dimensions also pose observational hurdles. These dimensions are thought to be curled up at extremely small scales, far too tiny for our current technology to detect. Section 7, Cosmic Echoes, searching for multiverse footprints in the cosmic microwave background. Despite the challenges, scientists are actively searching for evidence of the multiverse. One promising avenue is the cosmic microwave background, CMB radiation. The CMB is a faint afterglow of the Big Bang, a snapshot of the early universe. Scientists believe that the process of inflation, which might have created the multiverse, would have left subtle imprints on the CMB. These imprints could take the form of temperature variations or patterns in the polarization of the CMB light. Finding these imprints would be a major breakthrough, providing strong circumstantial evidence for the existence of a multiverse. Several experiments, both ground-based and space-based, are currently searching for these elusive signals. Another intriguing piece of the multiverse puzzle comes from the fine-tuning problem. The laws of physics, as we know them, seem to be perfectly calibrated for the existence of stars, galaxies, and life. Even slight variations in these laws could render the universe sterile and lifeless. Some scientists argue that this fine-tuning is not a coincidence but a hint of the multiverse. In a multiverse scenario, there could be countless universes with different sets of physical laws and constants. We find ourselves in a universe with life-permitting conditions because, well, we have to. If the universe were any different, we wouldn't be here to observe it. This is known as the anthropic principle. While the anthropic principle doesn't prove the multiverse, it offers a compelling explanation for the seemingly improbable fine-tuning of our own universe. The multiverse remains a topic of intense debate among scientists and philosophers. Some argue that it's not a scientific theory at all because it's currently untestable. They say it's more like a philosophical idea. Others counter that the multiverse is a natural consequence of our best scientific theories. They argue that we shouldn't shy away from exploring its implications just because it's difficult to test. The debate highlights the evolving nature of science. As our understanding of the universe expands, so too do the boundaries of what we consider to be scientific. The multiverse pushes these boundaries, challenging us to rethink the nature of reality and our place within it. The idea of a multiverse, if true, has profound implications for our understanding of the cosmos and our place within it. It suggests that our universe is just one tiny island in an infinite archipelago of possibilities. This realization can be both humbling and awe-inspiring. It diminishes our perceived significance in the grand scheme of things, while simultaneously expanding our horizons to encompass a reality far vaster and stranger than we ever imagined. The multiverse also raises profound philosophical questions about the nature of identity, free will, and the meaning of existence. If there are infinite versions of ourselves out there, making different choices and living different lives, what does it mean to be us? These questions may not have easy answers, but they force us to confront the vastness of the unknown and to embrace the mysteries that still lie hidden within the fabric of reality. The multiverse remains a mystery, but it's a mystery that continues to captivate our imaginations and drive scientific inquiry. Whether it's through searching for cosmic echoes in the CMB, unraveling the mysteries of string theory, or exploring the philosophical implications of infinite possibilities, the quest to understand the multiverse is an ongoing adventure. As we delve deeper into the nature of reality, we are likely to encounter even more mind-boggling concepts and theories. The multiverse is just one example of how science continues to push the boundaries of our understanding, and to reveal the universe to be a far stranger and more wonderful place than we ever imagined. So, the next time you look up at the night sky, remember that what we see might be just a tiny glimpse of a much grander and more complex reality. The multiverse, with all its mysteries and wonders, awaits those brave enough to explore its infinite possibilities.